This is the EdExcel GCSE 9-1 Higher Paper 2, which is a calculator paper and it's from the sample papers. Question number 1. Frank, Mary and Seth shared some sweets in the ratio 4 to 5 to 7. Seth got 18 more sweets than Frank. We have to work out the total number of sweets they shared. Well, what we can do over here is unsimplify the ratio until the difference between Frank and Seth is 18. So currently we've got the ratio F to M to S equaling 4 to 5 to 7. Now the difference here will show the difference in red. 7 take away 4, you'd find that to be 3. If we unsimplify, we have 8 to 10 to 14, and the difference between 8 and 14, that's 6. If we unsimplify once again, we'd have 12 to 15 to 21, and the difference between 21 and 12, that's 9. If we unsimplify again, we have 16 to 20 to 28, and the difference between 28 and 16, that's 12. If we unsimplify again, we have 20 to 25 to 35, and the difference between 35 and 20, that's 15. And if we unsimplify again, we have 24 to 30 to 42, and the difference between 42 and 24, that's 18. So you can see here, Frank got 24 sweets, Mary got 30 sweets, Seth got 42 sweets, and therefore the total number of sweets they shared, we have 24 for Seth, 30 for Mary, and 42 for Seth. And it turns out here we get 96. Question 2. PQR is a right-angled triangle. That's what we see here. We have to work out the size of the angle marked X. Give your answer correct to 1 decimal place. Well, if we label our sides, here you can see PQ with length 5 centimeters would represent the opposite, of course it's opposite the angle. And the longest side, PR, with length 14 centimeters, corresponds to the hypotenuse. And what connects the opposite to the hypotenuse is sine. Sine x is equal to the opposite, 5, divided by the hypotenuse, 14, and therefore x is equal to the inverse sine of 5 over 14. So if we work this out, the inverse sine of 5 over 14, you'd find that to be 20.92, etc., which to 1 decimal place, we have 20.9 degrees. So x is 20.9 degrees to 1 decimal place. Question 3. Here are the first 4 terms of an arithmetic sequence. We have 6, 10, 14 and 18, and for part A we have to write an expression in terms of n for the nth term of this sequence. You can see the difference between each of these terms is plus 4. So we have a 4n, and if we find out the 0th term, we do the opposite of plus 4, which is minus 4. 6 take away 4, you'd find that to be 2. So we have 4n plus 2 as the nth term of the sequence. And now for part B, the nth term of a different arithmetic sequence is 3n plus 5. We're questioning if 108 is a term of this sequence. Show how you get your answer. Well, what we can do over here is set the 3n plus 5 equal to 108. And if we solve for n and get an integer, i.e. a whole number, that means 108 is part of the sequence. So if we subtract 5 from both sides, you'd find 3n to equal 103. And if we divide 103 by 3, of course we can't simplify this any further, so n equaling 103 over 3 is not an integer, and because it's not an integer, we can conclude 108 is not part of the sequence. Question number 4. Axel and Lethner are driving along a motorway. They see a road sign. The road sign shows the distance to junction 8. It also shows the average time drivers take to get to junction 8. So to junction 8 is another 30 miles and it'll take 26 minutes to get there. The speed limit on the motorway is 70 miles per hour, and Lethner says we will have to drive faster than the speed limit to drive 30 miles in 26 minutes. Is Lethner right? You must show how you get your answer. Well, what you'd first of all notice over here is here we have minutes and here we have miles per hour. So one thing we can do is convert the minutes into hours. To go from minutes to hours, we would have to divide by 60, and to go from hours to minutes, we would have to multiply by 60. So therefore, 26 minutes is equal to 26 over 60 hours. Now, we should know already that speed is equal to the distance over time. So, the speed is equal to, so let's just write this down, the average speed is equal to the distance, which is 30 miles, over the time, which is 26 over 60 hours. So if we work this out, 30 divided by 26 over 60, this is 69.23 etc. miles per hour. And of course, this is less than the speed limit of the motorway, 70 miles per hour, and therefore we can conclude Lethner is incorrect. Question number 5. The table shows some information about the foot lengths of 40 adults. And for part A, we have to write down the modal class interval. First of all, the modal class means the class which is most common, and that's the one with the highest frequency, and you can see that's the one corresponding to 12 adults, which is this interval here. The interval 22, which is less than or equal to f, which is less than or equal, which is less than 24. And now for part B, we have to calculate an estimate for the mean foot length. Well, before we do anything else, we need to find out the midpoints of each of these intervals. Here we have 17, here we have 19, here we have 21, here we have 23, and here we have 25. We now need to find out the frequencies multiplied by the midpoints. 3 times by 17, that's 51. 6 times by 19, that is 114. 10 times by 21, that's 210. 12 times by 23, that's 276. 9 times by 25, that's 225. Now we need to find out the sum of all the adults. So here we've got 3 plus 6 plus 10 plus 12 plus 9. You'd find this to equal 40. And if we find the sum of these, 51 plus 114 plus 210 plus 276 plus 225, you'd find this to equal 876. So now we can find the mean. The mean is equal to 876 over 40. So if we work this out, we divide this by 40, and it turns out we get 21.9. So an estimate for the mean foot length is 21.9 centimeters. Question number 6. Triangles ABD and BCD are right-angled triangles, and we have to work out the value of x, give your answer to 2 decimal places. Well, in order for us to work out x over here, of course, we can use Pythagoras to help us. Now, we need to work out this length here using Pythagoras, and then we can use Pythagoras in this triangle to find out this length. So this length, BD, through Pythagoras, because 10 is the hypotenuse, it's the longest side, BD through Pythagoras is equal to 10 squared, take away 5 squared, square rooted. So if we work this out, we have the square root of 10 squared, take away 5 squared, which is 5 root 3. So we have 5 root 3. Let's add this here. We have 5 root 3 centimeters. We can now find out x using Pythagoras. X is equal to 4 squared plus 5 root 3 squared, square rooted. So if we work this out, we square this, and then we add on 4 squared, and then we square root this. It turns out we get root 91. And if we work that out as a decimal, we get 9.53, etc. So therefore, to 2 decimal places, we round this to 2 decimal places, we get 9.54. So we have x being 9.54, correct to 2 decimal places. Question 7. The graph of y equals f of x is drawn on the grid, that's what we see here, and for part A we have to write down the coordinates of the turning point of the graph. Well, the turning point would correspond to the maximum point, which is here. And you can see this has coordinates 1, 4. So therefore, the coordinates of the turning point will be 1, 4. And now for part B, we have to write down the roots of f of x equals 2. So what we need to do is draw a horizontal line at y equals 2. So let's just do that. We draw a horizontal line here. So this is y equals 2. And now we need to find out the intersection between this straight line and the curve. So if we do that, let's just spin this ruler around like so. So we have a solution here, and we also have another solution here. So therefore, we have a solution at x equals minus 0.4 and x equals 2.4. So therefore, the roots to this equation, we have x equals minus 0.4 and 2.4. And now for part C, we have to write down the value of f of 0.5. What this means is we substitute in the value of 0.5 for x and see what the corresponding y value is. So if we draw a vertical line up from here, and then from here, if we draw a horizontal line, you'd find when x is equal to 0.5, y is equal to 3.7. Okay, so let's just change the color here to set orange. So here we've got 1, 4. So here we've got the value of f of 0.5 being 3. For question 8, in a box of pens there are 3 times as many red pens as green pens and 2 times as many green pens as blue pens. For the pens in the box, we have to write down the ratio of the number of red pens to the number of green pens to the number of blue pens. Well, if we let x equal the number of blue pens, that means that the number of green will equal 2x because we have twice as many green as blue. And it also means that the number of red pens we have is equal to 2x multiplied by 3 because we've got 3 times as red as green. So the number of red pens we've got is 6. And therefore the ratio of red to green to blue is equal to 6 to 2 to 1. So we have 6 to 2 to 1. Question 9. ABCD is a rectangle and EFGH is a trapezium. All measurements are in centimeters and the perimeter of these two shapes are the same. We have to work out the area of the rectangle. So what we can do over here then is for the rectangle ABCD is find out the perimeter. So the perimeter here is equal to 3x plus 4 plus the 4x, and then here we'd have another 3x plus 4, and here we'd have another 4x. And if we simplify all this, it turns out here we get 14x plus 8. And if we consider the perimeter of E, F, G, H, we have x minus 3 plus 5x plus 7x minus 3 plus another 5x. So it turns out here we'd get 18x minus 6. And from this, if we find out what x is, we can use this information to find out what the area of the rectangle is. So we have 14x plus 8 equaling 18x minus 6 because the perimeters are the same. So if we subtract 14x from both sides, we'd have 4x equals, well, and if I add 6x to both sides, we'd have 4x equals 14, and therefore x is equal to 7 over 2. So knowing that x is equal to 7 over 2, we can conclude here that, well, let's just draw out the rectangle again. If we draw out the rectangle, we have A, B, C, and D. Well, here we've got 3x plus 4, so we've got 3 times by 3.5 plus 4, that's 14.5. So here we've got 14.5 centimeters, and here we've got 4x, so here we've got 4 times by 3.5, which is 14. So here we've got 14 centimeters, and therefore the area, that's equal to 14.5 multiplied by 14. So if we work this out, you'd find we get 203 centimeters squared. So the area is 203 centimeters. Question 10. Katie invests £2,000 in a saving account for 3 years. The account pays compound interest at an annual rate of 2.5% for the first year, X% for the second year, and X% for the third year. There is a total amount of £2124.46 in the savings account at the end of 3 years. We have to work out the rate of interest in the second year. So, a couple of ways to think about this. We've got the original amount, 2,000, and the interest in the first year is 2.5%. So we multiply by 1.025. So this is the amount for the first year. Okay. And then in the second and third year, the amount is X%. So then we multiply by 1 plus x over 100 to the power of 2. And that's because we're repeating it. So here is the amount for the second and third year. And at the end of the 3 years, the total amount we have is 2124.46. We need to find out the rate of interest in the second year, so we need to find out what x is. So let's tidy all this up. You can see here, we've got 2,000 being multiplied by 1.025. So here we get 2050 multiplied by 1 plus x over 100 squared, and this is equal to the 0.46. And if we divide the 2124.46 by 2050, you can see here that 1 plus x over 100 squared is equal to 1.036, etc. So now if we square root 1 plus x over 100 is equal to 1.017, etc., subtracting 1 from both sides and then multiplying by 100, you'd find x to equal 1.799, etc. And therefore, the rate of interest in the second year is 1.80 to 3 significant figures. So we have 1.80% to 3 significant figures. And now for part B, Katie goes to work by train. The cost of a weekly train ticket increases by 12% to £225. We have to work out the cost of a weekly train ticket before this increase. Well, if we increase the train price, that means the 112.5%, so this is with the increase, corresponds to the £225. And we need to find out what the original amount was. So we need to find out what 100% would represent. But before we do anything else, we can actually find out what 1% represents. And to do this, of course, we need to divide both sides by 112.5. So we need to divide both the left and the right by 112.5. And if we do that, 225 divided by 112.5, this is of course 2. And then if we multiply by 100, so now if we multiply this by 100, 2 times by 100 is 200. So before the increase, the price was £200. Question 11. S and T are points on the circumference of a circle with centre O. PT is a tangent to the circle and SOP is a straight line, and the angle OPT is equal to 32 degrees. We see all this in the diagram above. We have to work out the size of the angle marked X. You must give a reason for each stage of your working. First of all, the angle OTP will equal 90 degrees, and that's because the angle between a radius and a tangent is 90 degrees. Let's just write that down. So OTP is equal to 90 degrees, and that's because the radius and the tangent are perpendicular to each other. Now, from this, we can find out the angle POT, recognizing that angles in a triangle add up to 180. So the angle POT, this is equal to 180, take away the 90, take away the 32, which is equal to 58. So this angle here is 58 degrees, and let's give a reason for our answer. Angles in a triangle sum to 180. Now with this we can find out the angle SOT, which is this angle here. So the angle SOT, this will equal 180 minus the 58, which is 122. The reason for that is we've got angles on a straight line which add up to 180. So let's just write this down. Angles on a straight line sum to 180. Now, SO is equal to OT, and that's because they're both radius. So SO is equal to OT because they're both radii, and therefore SOT is a isosceles triangle. So therefore triangle SOT is isosceles, and therefore this angle here will be X as well, because the base angles in a isosceles triangle are equal. So what we can therefore conclude from here is the angle TSO is equal to the angle SOT, which is equal to X. And again, recognizing that angles in a triangle add up to 180, we therefore have 122 plus X plus another X equals 180. So let's write down the reason for this. So the reason is angles in a triangle sum to 180, and therefore you can find X to equal 29. So X is 29. Question 12. A and B are two sets of traffic lights on a road. The probability that a car is stopped by lights A is 0.4. If a car is stopped by lights A, then the probability that the car is not stopped by lights B is 0.7. If a car is not stopped by lights A, then the probability that the car is not stopped by lights B is 0.2. We have to complete the probability tree diagram for this information. So, first of all, the probability that a car is stopped by lights A is 0.4, so let's add this here. And therefore the probability that it's not stopped by light A will be 1 take with 0.4, which is 0.6. Of course, we need to remember that probability adds up to 1. Now, we were told that if the car is stopped by A, then the probability that it's not stopped by B is 0.7. We were told that here, and therefore the probability that it stops at light B, given it stops at A, is 1 take with 0.7, which is 0.3. Now, if a car is not stopped by light A, then the probability that the car is not stopped by light B is 0.2, so that refers to this over here, and therefore 1 take with 0.2 is 0.8. So the probability that it stops at B, given that it does not stop at A, is 0.8. Now, Mark drove along this road. He was stopped by just one of the sets of traffic lights. Is it more likely that he was stopped by lights A or lights B? You must show your working. So, key in this question, he was just stopped by one of the sets of traffic lights. So what we need to calculate over here is the probability that he stops at A and then does not stop at B. We also need to calculate the probability that he does not stop at A and then the probability that he stops at B. And then we compare these and see which one is greater. So probability that he stops at A, then not at B, that will be 0.4 times 0.7. So this is 0.28. And probability that he does not stop at A, that's 0.6. And probability that he stops at B then is 0.8. So if we work this out, this is 0.48. So therefore, we can conclude that he's most likely to be stopped by light. Question 13. D is inversely proportional to C. When C is equal to 280, D is equal to 25. We have to find the value of D when C is 350. Well, first of all, we know that d is inversely proportional to c, so we can write this down in terms of what we see here. We have d inverse proportional sign and then 1 over c. And we can now replace the proportionality sign with an equals k. So we have d equals k over c. Now let's use these conditions. C is 280, d is 25. So we have 25 equals k over 280. So therefore, k will equal 25 times 280, which is 7,000. So therefore, k is 7,000. And knowing that k is 7,000, we can conclude d is equal to 7,000 over c. Now we need to find out the value of d when c is 350. So when c is equal to 350, d is equal to 7,000 over 350, which is 20. So the value of d when c is 350 is 20. Question 14. We have to prove algebraically that 2n plus 1 all squared minus 2n plus 1 is an even number for all positive integer values of n. So first of all, let's calculate 2n plus 1 all squared. So if we work that out, we end up with 4n squared plus 4n plus 1, and then we subtract off 2n plus 1. So if we tidy this up, you can see here we have 4n squared, and then we've got 4n minus 2n, so that's positive 2n, and the plus 1 and the minus 1 cancel out. And we can tidy this up even further. We can take out a 2 as a common factor. So we have 2 lots of 2n squared plus 1. And of course, because n is a positive integer, 2n squared plus 1 will also be a positive integer. So 2 times by a positive integer is even. So let's just write that down. So as n belongs to a set of positive integers, 2n squared plus 1 also belongs to a set of positive integers, and therefore 2 times by an integer is even. Question 15. We have to prove algebraically that the recurring decimal 0.25, where the 5 is recurring here, has the value 23 over 90. Well, first of all, let's write out the 0.25 recurring. So here we have 0.2, and then we have the 5, which is being repeated. Now, because only one digit is being repeated, well, before that, here, we're going to let x equal this value. And because one digit is being repeated, we multiply this by 10 and this by 10, so we have 10x, which is equal to 2.555555, etc. So now we subtract these, so we have 9x, which is equal to 2.3, and of course this works out quite nicely because these all cancel out. Okay, so x will therefore equal 2.3 over 9, which is equal to 23 over 90. Question 16, we have to show that 1 over 6x squared plus 7x minus 5 divided by 1 over 4x squared minus 1 simplifies to ax plus b over cx plus d, where a, b, and c and d are integers. Well, before we do anything else, what we can do is flip the second fraction and change the divide sign to a times. So we would have 1 over 6x squared plus 7x minus 5 multiplied by 4x squared minus 1 over 1. We now need to factorise, so we need to factorise the 6x squared plus 7x minus 5 and the 4x squared minus 1. So if we factorise the 6x squared plus 7x minus 5, we get 3x plus 5 lots of 2x minus 1, and we've got the 1 on the top. And if we factorise the 4x squared minus 1 as a difference of two squares, we've got 2x plus 1 lots of 2x minus 1. Okay? And then obviously on the bottom we've got the 1. So if we see what cancels, well, this cancels with this, and also this cancels with this. So what we're left with then is 2x plus 1 over 3x plus 5. So we have 2x plus 1 over 3x plus 5. Question 17. The diagram shows a sector of a circle of radius 7 centimeters, and we have to work out the arc length AB. Well, AB, that will equal a proportion of the entire circumference. Now the circumference is equal to 2 multiplied by pi multiplied by the radius, which is 7, and we have a proportion of that, and the proportion we've got is 40 over 360. So we have 40 over 360 multiplied by 2 times pi times 7. So if we work this out, we have 40 over 360 multiplied by 14 pi, which is 4.88, etc. So to three significant figures, we have 4.89 centimeters to three significant figures. Question 18. M is equal to the square root of s over t. S is equal to 3.47, correct to three significant figures, and t is equal to 8.132, correct to four significant figures. By considering bounds, we have to work out the value of m to a suitable degree of accuracy. Give a reason for your answer. Well, what we need to do over here is find the upper and lower bounds of s and t. So, the upper bound of s, this is equal to 3.475, and the lower bound of s, that's equal to 3.465. The upper bound of t, that's equal to 8.1325, and the lower bound of t, that's equal to 8.1315. With this, we can calculate the upper bound of m and the lower bound of m. So for the upper bound of m, we want m to be as big as possible. So we want the biggest numerator, the smallest denominator. So we have the upper bound of s square rooted divided by the lower bound of t. Okay. So if we work this out, we have the upper bound of s, which is 3.475, and then we need to square root this, of course. And if we divide by the lower bound of t, we divide by the 8.1315. So let's work this out. And I think at this point it will be a good idea to display all the figures your calculator shows. So here we've got the square root of 3.475 divided by 8.1315, which is 0.2292486 okay? And similarly, the lower bound of m, this is equal to the lower bound of s over the upper bound of t, and of course the lower bound of s is being square rooted. So here we've got the lower bound of s, which is 3.465, and we square root this, and then we divide by upper bound of t, which is 8.1325. So if we work this out, we have the square root of 3.465 over 8.1325. And it turns out here we get 0.2288903.839. Okay, so therefore you can conclude to a suitable degree of accuracy m is equal to 0.299. The reason for this, both the upper bound of m and the lower bound of m round to this value. Question 19, the graph of y equals f of x is shown on both grids, so that's what we see here. And for part A, on the grid above, we have to sketch the graph of y equals f of minus x. Well, the graph of f of minus x is a reflection in the y-axis. So we need to reflect this graph in the y-axis. So it's important to note that this point is reflected in the y-axis. So is this point, and if I reflect this, point, we're going to have this point being at 4, and this vertex is at 2, and then we also have these points here. So if we now sketch the graphs, we have something looking like this. Okay, so this is the graph y equals f of minus x. Now for part B, we have the graph of minus f of x plus 3. Well, first thing we need to do is sketch the graph of minus f of x. So that will look something like this. If I just show the coordinates, we have something looking like this. Okay, just draw it neatly. Something looking like this. And then what we need to do is shift this up by 3 units. So we've got 1, 2, 3. So this is the graph of y equals minus f of x plus 3. Question 20, we have to solve algebraically the simultaneous equations x squared plus y squared equals 25 and y minus 2x equals 5. Well, let's call this first equation equation 1, and let's call this second equation equation 2. Now, If we rearrange for y, we can substitute that into equation 1. So from equation 1, you can see that y is equal to 2x plus 5. We'll call this equation 3. And now we will substitute in equation 3 into equation 1. And if we do that, we've got x squared plus y squared, which is now 2x plus 5, all squared. This is equal to 25. So now we need to tidy all this up. So we have x squared plus 4x squared plus 20x plus 25 equals 25. Of course, the 25 here cancels with this 25 here. So we have 5x squared plus 20x equals 0. So therefore we have 5x lots of x plus 4 equals 0. And therefore x is either equal to 0 or minus 4. Now when x is equal to 0, y will equal, if we substitute back into equation 3, we have 2 lots of 0 plus 5, which is 5. And when x is equal to minus 4, y is equal to 2 lots of minus 4 plus 5. So we've got minus 8 plus 5, which is minus 3. Now, we can therefore conclude for our solutions, we have x equals 0, y equals 5, and x equals minus 4, y equals minus 3. Okay? Question 21. In triangle RPQ, RP is 8.7 centimeters, PQ is 5.2 centimeters, and the angle PRQ is 32 degrees. For part A, assuming that angle PQR is an acute angle, we have to calculate the area of triangle RPQ. Give your answer correct to 3 significant figures. Now before we do anything else, I think it might be a good idea to draw a diagram to help visualize this triangle. So what you can see here, we've got the triangle RPQ. You'd find that this angle PQR is acute, and we've got the relevant dimensions. Now we need to find out the area of the triangle. Now for us to find out the area of the triangle, we need 2 lengths and an angle in between. So we need to find out the angle P. But the problem is here, we can't find the angle P given this information straight away. However, because we have Q, which is unknown, we can find out what Q is and use the fact that angles in a triangle add up to 180 to find out what P is. This is because we can use the sine rule. We have a length and an angle opposite it, and we have a length and an angle opposite it. So, if we use the sine rule, we have here sine Q. This is sine Q over 8.7. This is equal to the sine of 32 over the 5.2. Now if we rearrange, we can find out what sine Q is. So sine Q is equal to, if we work this out on our calculator, we have the sine of 32 over 5.2 multiplied by 8.7. It turns out here we get 0.88, etc. So we have sine Q, which is equal to 0.88, etc. So therefore we can find out what Q is. Okay? So if we inverse sine this, we'd find Q to equal 62 0.44, etc. So let's store this into our calculator. So this angle here is 62.4, etc. degrees. Okay? So that's this angle here. Now we can find out the angle P. So therefore, the angle P is equal to 180 minus the 32 minus the 62.4, etc. So if we work this out, we've got 180 minus what we've just worked out for that angle. So 180 minus this minus the 32, which is 85.5, etc. So this angle is 85.5, etc. So let's show this in our diagram. Okay, so now we have an angle in between two lengths, and therefore we can find the area. The area will equal 1/2 times by 8.7 times by 5.2 times by the sine of 85.5, etc. So we can find out the area. We have the sine of this being multiplied by 1/2 times 8.7 times the 5.2. So if we work this out, we get 22.55, etc. So therefore, to three significant figures, we have 22.6. Now for part B, slightly more tricky. If you did not know that angle PQR is an acute angle, what effect would this have on your calculation of the area of the triangle RPQ? Well, to do this, I think it will be a good idea to draw out the situation. Okay, so here we've got R, we've got P over here, and currently we have, if I draw a line here, okay, if I just draw a straight line, then what we have currently from part A is Q over here from A, and this angle here is acute. Okay, now what we're saying is we could have, of course, an obtuse angle here, so therefore Q would go here for part B, and therefore this angle here would be obtuse. And we're saying if this angle is obtuse, what would the effect be on the area of the triangle? Well, if we work out, well, we know here that the acute angle we've just worked out to be 62.4, etc. So here we have 62.4, etc. Now, this length over here has to remain the same as 5.2, and before, obviously, it was 5.2. So if we work out the obtuse angle here, the obtuse angle will equal 180 minus that value we had, which is 117.5, etc. Okay, and therefore, well, so far we know that this is still 8.7. This angle then would be, if we work this out, well, of course here we need to recognize we still have the 32. This angle here would be 180, take away the 32, take away the answer we've just found here, which is 30.5, 0.4, etc. Okay? So this angle is, if we work it out in green, 30.4, etc. Now, if this is the case, the area then would equal 1/2 times 8.7 times 5.2 times by the sine of 30.4, etc. So if we work this out, we have the sine of this, and then we multiply this by 1/2, then 8.7 and 5.2. So here we get 11.46, etc. centimeters squared. And what you can see from here to here, we can conclude that the area would decrease. Okay? So that's the effect if we did not know that PQR was acute. We've assumed now that is obtuse. Question 22. A frustum is made by removing a small cone from a large cone as shown in the diagram. Now we know that the volume of a cone is equal to 1/3 pi r squared h. And a frustum is made from glass, and the glass has density 2.5 grams per centimeters cubed, and we have to work out the mass of the frustum, give your answer to an appropriate degree of accuracy. So here, first of all, we have something involving a density and the mass, and we need to think to ourselves what formula connects them all. Of course, we know already that density is equal to the mass over the volume. Okay, so let's just show that. Density is equal to mass over volume. So we need to find out what the volume is to find out what the mass is, because we already know the density. So we can do that by finding out the volume of the large cone, the volume of the smaller cone here, and then subtracting them both will give the volume of the frustum, and from that we can find out the mass. So what we need to do is find out the volume of the large cone. So for the large cone, the volume will equal, if we use this formula, 1/3 times by pi times by radius squared. Well, if here the diameter is 12, the radius here will be 6, so we multiply by 6 squared and times by the height, which is 15. And if we work this out, we get 180 pi centimeters cubed. And for the small cone, okay, for the small cone, we've got V equals 1/3 times by pi. Well, here we don't know what the radius is yet, but we can figure it out by drawing two triangles. So here we've got a little triangle, as we see here, and then we've got a larger triangle, as we see here. Okay, so this is our larger triangle. Okay, now here we know that this length is 12 from here. We know that the height over here is 15, and if we subtract 10 from 15, we'd find this height here to be 5. And because here you can recognize the scale factor from the small shape to the large shape is 3, so to go from small shape to large shape, we times by 3, because 5 times by 3 gives 15. To go from the large to the small, we'd have to obviously divide by 3. So 12 divided by 3, that's 4. So the radius of the small cone will be half of 4, which is 2. So we multiply here by 2 squared times by the height, which we've just said is 5. And if we work this out, we get 20 pi over 3 centimeters cubed. And therefore, for the frustum, the volume will equal 180 pi minus 20 pi over 3, which is 520 pi over 3 centimeters cubed. Now we need to find out what the mass is, so we multiply the density by the volume. So therefore the mass is equal to density, which is 2.5 grams per centimeters cubed, multiplied by the volume, which is 520 pi over 3 centimeters cubed. So if we work this out, we get 1300 pi over 3. And if we write this down to a suitable degree of accuracy, we've got 1300 divided by 3, and then multiply this by pi. We get 1361.35, etc. grams. So to a suitable degree of accuracy, say to 3 significant figures, we have 1360. Okay? And I think it might be worth writing down the accuracy of what we worked this out to be. So that is the end of the paper.